So this is the api.js file. I just wanted to walk through it and explain all the different methods in this file because it forms the basis for a lot of the code that we write. This is the file that contains the functionality used to make any of the requests to the server from within our React applications. So let's kind of walk through these. Probably the best place to start, excuse me, is with the public methods, because these are the ones that are actually exposed to the outside world. And you can see that here where we say var API equals this stuff, and then we export that as the default object. There's a get, which just does a simple get request. There's no caching. It does dispatch an event, and I'll talk about that here in a second. But we have get, post, put, and delete. So those are the common RESTful actions. There's also this async cache get. So we'll need to kind of discuss that one in a little bit more depth because it handles some caching here at the API layer. Then there's also this query string from. This is just a method that generates a query string given some parameters as an object. So for example, if I have a set of parameters that look like this, and then I pass that in as the params, then the query string will come out looking like this. And then it'll add ampersands and whatever else that you need to generate a valid query string. Okay, so going back to the get, what this does is if you pass it a key, that key is a constant value that is then dispatched to the stores. If you pass it a null, then it will not do a dispatch, but it will return a promise to you. And then you can use that promise. We frequently use that in actions that need to make multiple calls to the server before dispatching anything to the store. So you might need to go, for example, and get a user and then get their profile and then put that data together in an action and then send that off to a store, for example. Something like that. We don't actually do that very often, but I think it came up in one or two situations, so we made that possible. The other parameters you pass to these other guys are a body. So whenever you do a post or a put, you need to pass it a body. And then, of course, with a delete, you just pass it the URL of the object, and it will delete it. Now, one of the things I think one of our faulty original design decisions was to put key first. We probably should have put URL first and put key last because key is an optional parameter. Had we put it last, then you wouldn't even have to pass it. We can just say if it's undefined, then return a promise. But we put it first, and so much code depends on this now that we have yet to refactor it. We might at some point, but so far we have not. In the cache get, however, we did refactor it. So you have to be a little cautious when you switch between a get and a cache get because we swap the URL, and then we also add this params in here so that you can pass that for the cache get. I think that before, with this URL in a GET request, we were expecting that you would pass the entire URL, including the query string. In the cache GET, we make it so that you don't have to pre-assemble the query string. You can do it through this params object. If you pass refresh true, then it will always go to the server. This is actually a really interesting method. It uses promises and generators, and it can be a little bit confusing when you first look at it because it's also an async method, which means it returns a promise. So typically you'll call this in one of our actions, which are called from components. And most of the time when you call an action inside of a component, you don't care when it returns. You just call it and you say, now it's your problem. You're not expecting a return value. So the async method actually works pretty well. So you can do an async await inside of the actions and then wait for this guy to return. Now, because it is asynchronous, right? Like you don't immediately get this back. It's not going to be called synchronously. It's going to return a promise that you can do a then on, or if you do an async await method, in other words, if your action is an async action, then you can do an await on a cache get. And then it looks like it's synchronous at that point, even though it's truly asynchronous. Then what this guy does is it checks to see, does this value exist in the cache? And it uses the URL to determine whether or not this request has been made before. And then if it has, it will go pull that request from the internal cache and return that immediately. If it has not been returned, if it has not been made before, then it will actually make the request to the server, put that response into the cache, and then return that value. If you pass a refresh, it will still return a value from the cache if it's available, and then it will return a second value when the response comes back from the server. So refresh means we're going to send data to the stores twice. The first time we're going to send it from the cache if it's available, and the second time we're going to send it from the server, the server response. And you can see that's what's going on right here. So as long as you pass it a key, all of this happens internally. You don't have to do anything inside of your action, which is actually kind of nice because you don't have to deal with this complexity. So if you pass it a key, it knows that it needs to dispatch that specific constant. And what happens right here is we call request.next, which is how you ask for a value from a generator function. And it will, let's see, sorry, I'm trying to remember. This one right here. Okay. So yeah, this one right here will get the value from the cache. And then as long as you've passed that refresh value in, it will make the server request right here because response.done will come back as false. And then it asks for the second value. Now, if the data was not in the cache, then when this request is made, it will make the request to the server and then return that response. When that comes back, then response.done will be true and this while loop won't execute. So it doesn't call you twice, or it doesn't provide two values if the data wasn't in the cache previously. Does all that make sense, or is that?
The basic idea that you call cache get and you call cache get with refresh, that two actions are going to be dispatched to the stores, the first with the cached value if it's there, and the second with the actual value when it gets here.
Right.
That's clear.
Okay. Okay. So now I'm guessing you were wanting to know how that's actually done. Is that right?
Well, I was in a situation that, and this might be varying off of the training that you're wanting to do here, where I needed to get information from the stores and then synchronize that with the setup of another store.
Oh, okay.
And I was thinking, wouldn't it be great if I could get a promise back from this without dispatching first, and then I could make sure that I set up these stores with the proper information. And what I'm doing now is inside of the store that's getting, the signal that, hey, I've got the information from the server. I'm taking that information to set up the second store. And the instance here is we're running quizzes, and quizzes have to have a timer running if they've got a timer set in the store. And I can't set that time until I have that information from the server. And of course, you don't want to put that in the component itself because you have state being managed on your timer's out. Okay, we're going to forcibly eject you from the quiz. So you don't want, the timer being set or reset as the component refreshes or re-renders for things.
Right. If you have two stores where one store depends on another, then the method that you want to look at is wait for.
Okay.
And that's actually going to be different than the code that we've looked at here. Let me pull it up. Yeah, because all of this code is just for talking to the server. But
yeah. My point being that, I mean, where I've got it right now, it works. I just thought that it would be nicer to do all of that information within the action itself.
Yeah, and actually that, I kind of prefer that. I think wait for can be a little bit complex, both to understand and to use.
Okay.
And it requires that you return, let's see, let's just pull up a quick example here. Let's see. Okay, so in this situation right here, you can see how we have this wait for method that says the flight dispatcher, I think, has to wait for the country store for whatever reason. But in order to do that, you have to have this dispatch token. And the only way to get that is when you set up your store, when you call the register method, it returns that dispatch token. So then the store has to basically export that dispatch token and then when a different store depends on the first store, it has to import that store and then get that dispatch token and wait for it.
Okay. Is a dispatch token the same as these keys that we were working with earlier?
No, the keys, these keys right here are simply constants.
Right.
They're things like user loaded, which indicates that a user's data has been loaded from the server, and then the store will have this big switch statement.
Correct.
And it just says, do I care about that key? And if it does something with it, and then it emits an event so that the views know that they need to come and ask for data. Okay. So yeah, that's a totally different thing. The dispatch token is something I don't think we have it in use in any of our projects because, like I say, I've tried to avoid inter-store dependencies as much as possible because it's hard for somebody coming into the project to know what's going on.
Yeah, I put a little to-do statement as I was putting it in saying, figure out a more explicit way to do this.
Yeah.
And I'm really not sure whether using that dispatch token would be any better.
Yeah, I don't think it would. I actually prefer what you're doing. So the different, the different methods inside of the API can return a promise. And so if what you really need is to get data for one store and then do some stuff with that and then update another store, and you can do that all within the context of a single action, then I would say do it that way. So that action could maybe call a get from the server, or a get and get data from the server, do something with that, call another get, or maybe based on that data, it needs to dispatch multiple events.
So here's the sticking point for me.
Okay.
I don't know if the dispatcher is deterministic. I mean, like, and I know I asked you about this earlier, but when I dispatch an event, when am I guaranteed that that has been handled entirely?
Oh, if you call, here, let's look, there's a little bit of code in here that actually, we have this dispatch response and we can just look at it here.
Okay.
So, dispatch, then, okay, so there's multiple layers happening here because you can see how it checks for the different error codes and whatever. But at the end of the day, this is what happens right here, this one little piece of code, dispatcher.dispatch, and then the action is that constant, and then there's some data. And you can structure this payload however you like. It's just this is how we chose to structure it.
Yeah.
That, when you call dispatch, it goes through the entire cycle. So
Okay.
I dispatch, a store picks that up, an event is emitted, the views update. When that is all done, then we roll back up the stack, and this returns.
Okay, so dispatcher will dispatch its stuff. Everybody who's registered to the dispatcher will have, execute their turn, and then those events are all handled after the dispatcher returns.
No, they're handled in the context of the dispatch.
In the context of the dispatcher, and then they say, "Hey, we've changed," and those changes are sorry here. And those changes, like the components, will update after the dispatcher returns.
No, the components are updating during the dispatch. So that's what I mean. Is like that whole process happens. Everything. Yeah, that's why you'll get the error. If sometimes you'll end up with this error in your console, it'll say cannot dispatch. You're in the middle of a dispatch or something like that. I don't remember the exact error, but that happens when you attempt to call an action when that dispatch is already happening. So, for example, we get new data from the server that is like a new user. And then we dispatch right here, and we say user loaded, and the data is the user data. And that makes its way out through the views. And then there's maybe one of the views that says component did update. And when it did update, it's like, hey, we got a new user. Now I want to call this other action. And if you do that, if you call that action while that whole dispatch process is going on, you'll get that error that says cannot dispatch. You're already dispatching.
Okay.
Yeah, the dispatcher's entire purpose for existence is to make sure only one of those happens at a time. And it only returns when everything is done. So,
okay.
Yeah.
That's good to know. So, jumping back to my original problem, I have a quiz, and I've got the data, when the quiz comes down, and I need to say, okay, now that the quiz store is updated, I need to set my timer store. And the way the API is set up here, that dispatch is going to happen. The whole quiz store is going to be up and going. And the second thing, the second line of my action then could be, okay, now that that's set up, I want to do a second dispatch with the data from that response.
Yeah.
I can't get, and then at that point, I'm going to have to query the store for that data.
Ooh. Yeah, I would
from the action.
typically not want an action querying the store.
Right.
But so you could.
So my original thought was, hey, wouldn't it be great if I could make a query, and instead of the query, if I could say API get, and API get didn't automatically dispatch, but brought me back the information so that I could dispatch based on the information that it comes back to both the quiz store and the timer store.
Yeah, and you can do that. And the way that you do it is when you call the get method right here,
right,
instead of passing that constant, pass a null right here.
Pass a null.
Yeah, and then this do request, where is it? Do request. This guy right here will return this promise to you.
Okay.
So now, because you've passed a null, you're entirely responsible for all the dispatching. Like, it won't do anything for you.
Great.
Yeah. And so then in your action, you'll get that promise provided to you by the get. You'll do that a promise.then, which will get you the data. And then you can just import the dispatcher. So just like we do right here.
Yep.
You import the dispatcher, and then you'll call dispatch just like this with whatever data you want to send out.
All right. And then I can dispatch twice and say, hey, here's the first event, make sure that's all done.
Yep.
Then dispatch the second time with the event, the timer store, and it should be good.
Exactly. Yeah.
Okay, so pass in null on the get and work with the promise. All right.
Yeah. Yeah. And I apologize for the API structure. I really wish that I had done this the opposite way, so you didn't have to pass a null. But yeah, we're just kind of stuck with that for now, unless we want to go rewrite all of our actions, and I just haven't wanted to do that. So,
don't blame you.
Yeah.
Okay.
All right.
Thank you very much.
You betcha. So good luck, and give it a try. And then if you still have questions, let me know. We can work.
Okay, we'll do.
Okay, thanks. Talk to you later.